Hello. Am I audible to all? Screen is not visible. Hello. I think I'm audible and screen. What is happening? Now visible. Okay. Hello. So good afternoon, everyone. In last lecture, we started our fourth chapter, that is equipment protection, right? So in equipment protection, actually there are four equipments which we are going to protect. That is, first is the transformer, then second is the alternator, that is generators, then third is the induction motor, and fourth one is bus bar protection is there. So first one we started the transformer protection. So actually in transformers there are different types of faults. Okay. So internal faults and external faults are there. So yesterday we have seen these faults, that is the overheating, winding faults, open circuit faults. External faults are there, overfluxing, earth faults, phase faults, interturn faults, core faults. Okay, and when we are considering the power transformers, that is big transformers which are used in for the transmission purpose. So for that we are using the tanks, transformer tanks are there. Okay, so the tank faults and cooling failure, uh, then tap changer faults are there. Okay, so such types of faults are there in this transformer protection. And now after that we have seen the overcurrent protection. Okay, using the phase and ground relays. Now overcurrent protection means when actually this overcurrent is occurring. So when there are number of faults, that is the single line to ground faults and phase to phase faults. Okay, these faults are nothing but the short circuit faults, and they are causing the high current of flow in the transformer. That's why we are using the overcurrent protection scheme. So in overcurrent protection, what we are doing, we are actually setting the value of that current, that maximum current, or we call it the pickup current, right? So that pickup current value is set in that relay. So if that current up to that pickup value, your transformer will be under normal operating condition. Means when that much current is flowing through the transformer, that time your transformer is in under normal working condition. But if such faults will occur, then the current will increase than this pickup current, and your relay will start operating. Okay, your relay will start operating. So there are different line to ground faults and phase to phase faults. So when we are considering the ground faults, so for ground faults the current value is low, the current value is low. But when we are considering the phase faults, okay, that time the current value is more. So this relay should operate for both these values. Okay, means for the, if there is earth fault, that time, means if there is low value of current, that time also your relay should operate. Also if there is a face to face fault, means that current is more, that time also your relay should operate there. Okay, so here this is the overcurrent protection using phase and ground relays. So these relays are used here. Actually, one transformer we are connecting. So here same diagram is there. That is, there are two cities at the two lines. Okay, here is your transformer. Okay, here is your transformer, and these two cities are connected here. Okay, through there is a restraining coil and operating coil. Suppose this one is the restraining coil. So three phases are there. So here they are connecting one relay. So if it is connected to ground, then that is, if it is phase to phase fault, then the relay will be connected between the phases, and if it is earth fault, then relay will be connected here. Okay. uh, Now, after that, we have seen the percentage differential protection of transformer. So this is the diagram for percentage differential protection of transformer. It is important. Here we are connecting this transformer in star and delta. Primary is connected in star and secondary is connected in delta. Then the CT primary is connected in delta. Okay. So to obtain the exact phase difference, we have to connect these both in different ways. Means if you are connecting the primary of your transformer in star, we should connect your CT secondaries in delta. If you are using this so, hello. So if you are connecting this transformer secondary in delta, you should connect the CT secondary in star. Okay, so and in between that, the circuit breakers are used here. So here are the restraining coils. Okay, all the phases of the CT second primary are connected to the respective phase of your CT secondary. Okay. Now, here you can see there is a restraining coil. Actually, whatever be the current flowing through this CT secondary from the primary side will flow through this restraining coil. Similarly, the current flowing from the star connected CT secondary will also flow through this restraining coil. Okay, means we are taking the tappings here. We are taking tapping means in this half coil there will be current from this primary side, and uh, in remaining half current flowing will be from this secondary side CT. Okay, means when the difference of current will flow. Okay, when the difference of current will flow, suppose here the current is I1, and from here current of flowing is I2. Okay, that current of flowing is I2. So this current is here, this current is flowing in the secondary winding. Okay, so that uh, if there is the same current, means if this I1 is equal to I2, okay, if this I1 is equal to I2, then what happens? There is normal operating condition. There is normal operating condition when I1 is equal to I2. Okay, uh, means there is no any fault occurred. If there is no any fault occurred, but if uh, then what will be the current flowing through this operating coil? What will be the current flowing through this operating coil? If there is normal working condition and I1 is equal to I2, what is the value of current flowing through this operating coil? Yes. Yes, anyone? Fast. What is the value of current flowing through operating coil? Pooja, Ashwini. Yes. Hello. So what is the current flowing through the operating coil? Yes. Anyone? Suvarna. So I just explained the concept. Okay, and I'm telling this I1 is equal to I2. Then what is the current flowing through this operating coil? If this I1 is equal to I2, if the same current is flowing through this coil, restraining coil, then what should be the current flowing through the operating coil? Because this is I1 minus I2. Okay, so when there will be some difference between the current, that current will flow through this overcurrent through this operating coil, right? So the current flowing through this operating coil is I1 minus I2. So if your I1 is equal to I2, if the current I1 is equal to I2, then what is the value of current flowing through this operating coil? If I1 is equal to I2, then this I1 minus I2 is equal to 0, right? Na? It is equal to 0, means 0 current will flow through this operating coil. If the current is not flowing through this operating coil, it means that your relay is healthy. Okay, means there is no any fault. But when any fault will occur, that may be the internal fault or that may be some external fault, means if any winding fault is suppose there, then what happens? There will be some difference between these two currents. Okay, suppose there is fault occurred in this primary winding only. Okay, then the current flowing through this primary will be different. Okay, and current flowing at the secondary will be different. So there will be some difference between the current, and that current will flow, that current difference will flow through the operating coil, and your relay will start operating. Okay, so that's why it is called the differential relay. Differential relay. Okay, means the difference between the current is flowing through the operating coil, then only your relay is operating. Okay, after that we started this point, that is harmonic restraint differential relay. In harmonic restraint differential relay, actually what is this relay? So in this type of relay, only remember that there are actually two types of currents. Okay, uh, means some currents are produced due to because of some means simple faults. Okay, because of some simple faults, or we can say that that fault is occurred due to the internal faults are there. Sometimes there are some internal faults, and sometimes these faults are severe, म्हणजे serious faults. Okay, some faults are serious faults. So which are those faults? Okay, are due to the inrush magnetizing current. Inrush magnetizing current means what? They are affecting your फॉर एक्झाम्पल कोर, म्हणजे कम्प्लीट कोरच डॅमेज होते, कम्प्लीट वाइंडिंग डॅमेज होते. ओके, सो इफ सच टाइप्स ऑफ फॉल्ट्स आर देअर, तर ते फॉल्ट्स कसे असतात? सिरियस फॉल्ट्स आहेत. ओके, म्हणजे कम्प्लीट जर वाइंडिंग किंवा कम्प्लीट कोर डॅमेज झालं, तर तुम्हाला कम्प्लीट म्हणजे ट्रान्सफॉर्मर maintenance cost will increase. Okay, that's why these are the serious faults. Okay, so uh, actually when we are considering that magnetizing inrush currents are there, that time they are also producing the harmonics, higher harmonics. I told you in last lecture only. And when there are simple faults, okay, when there are simple faults, that time whatever harmonics produced, these are of fundamental, these are fundamental harmonics. Okay, fundamental harmonics. So what we have to do, if the harmonics are fundamental, okay, if the harmonics are fundamental means, if when we are comparing the waveforms, okay, when we are comparing the waveforms, actually the sine waves are there, but when we are comparing the waveforms, that time we have to identify the fundamental harmonics and the higher harmonics, higher order harmonics, that is the third, fifth, and seventh order harmonics are there. Okay, so what we have to do means, if there are only the fundamental quantities are there, or fundamental harmonics are there, which are caused by the simple faults. Okay, so we have to compare this with the harmonics produced by this magnetizing inrush currents. Okay, inrush currents or conditions. Okay, so what we have to do, we have to apply some filters. Okay, apply some filters to reduce these harmonics. म्हणजे ऍक्च्युली काय करायचंय आपल्याला, आता जर सिंपल फॉल्ट्स असतील तर ते सिंपल फॉल्ट्स आपण काय करू शकतो, by using our relay we can detect that fault. Okay, means we can use simply we can measure the current flowing through that operating coil, and if the current flowing through that operating coil will becomes more, then your relay will operate. Okay, that time what happens actually, restraining, there is a restraining coil also, but in that restraining coil, when this operating current becomes more, that restraining force becomes low, right? That restraining force becomes low, and your relay starts operating immediately. Okay, but sometimes what happens, there are some more harmonics, means due to these magnetic inrush currents, more harmonics are there. So to reduce these harmonics, what we are doing, we are simply what we can holding, or we are increasing this restraining force. Okay, we are increasing this restraining force, so that if there is a fundamental harmonic, that will be detected, or that is sensed. Okay, that is sensed by that operating coil only. And if there will be more harmonics, okay, means third, fifth, seventh order harmonics will be there, so that will be resolved by this restraining coil. Okay, by the restraining coil. So म्हणजे याच्यामध्ये काय करतात, तर आपले ऑपरेटिंग कॉइल कधी ऑपरेट होते, तर किंवा रिले किंवा ऑपरेट होतो, तर एखादी पिकअप व्हॅल्यू तुम्ही सेट केलेली असते तेव्हा. मग फंडामेंटल साठी काय करायचंय आपल्याला, म्हणजे ज्या वेळेला सिंपल फॉल्ट्स ऑकर होतील, तर त्यावेळेला फक्त तुमचं सिंपल रिले हा ऑपरेट झाला पाहिजे, अशी कंडिशन साठी, फॉर दॅट कंडिशन दिस सर्किट इज यूज. ओके, ऍक्च्युली we are protecting the transformer. Here is one CT at the primary side, next CT at the secondary side. Okay, so we are giving that CT secondaries, okay, to the operating coil only. Okay, means whatever be the circuit we have seen in previous, it is same, but it is through this rectifier unit. Okay, so and here we are using some filters, that is the XC and XL are used here. Okay, for removing these harmonics here. Okay, so here when there are fundamental harmonics only, means when the faults are simple, that time we are setting value of current, and whatever current will flow through that operating coil, that time your relay will operate. Okay, it means that that uh, uh, higher harmonics are not sensed by this. But if there are higher harmonics, means if the magnetic inrush current is flowing, okay, means there are serious faults. That time what happens, this restraining coil becomes sensitive. Okay, it becomes sensitive. Okay, so that it will operate. Okay, uh, it will operate there. So here this is the difference only here. म्हणजे सिम्पली जेव्हा एखादा सिंपल फॉल्ट असेल त्यावेळी हे ऑपरेट होईल फक्त, आणि ज्यावेळी एखादा सिरियस फॉल्ट असेल त्यावेळी दिस प्लस दिस, ओके, विल ऑपरेट. मीन्स थोड्या वेळासाठी जेव्हा कमी करंट किंवा कमी लेवलचे हार्मोनिक्स असतील ते थोड्या वेळासाठी रिस्ट्रेनिंग कॉइल इज यूज फॉर होल्डिंग दॅट circuit, we can say. Okay, so this is the harmonic restraint differential relay. Then next is the Buchholz relay for incipient faults. So what is mean by this incipient faults? Incipient faults means what? Yes, what is mean by incipient faults? Yes, anyone? Hello, what is mean by incipient faults? So these incipient means these are the slowly developing faults. Okay, incipient faults means slowly developing faults. So these faults are occurring in the transformers, and for that purpose, to protect the transformer from these incipient faults, that is slowly developing faults, we are using this Buchholz relay. Okay, so this Buchholz relay, where actually it is mounted. So all of you know the conservator. Okay, all of you know the transformer tank, right? Yes. You have studied this in electrical machine designs. Okay, all the transformer structure you have seen. So in between that transformer tank and that conservator, your Buchholz relay is located. So this relay is a safety device mounted on oil-filled power transformers and reactants equipped with an external overhead oil reservoir, that is the conservator. Okay, so this relay is gas actuated relay. Gas actuated relay means what? Actually, when there will be any fault occurring in that transformer, okay, occurring in that transformer means suppose insulation काहीतरी breakdown झाले किंवा काहीतरी core fault झालाय. Okay, core fault. Okay, so sometimes oil in that transformer get reduced. Okay, means any type of fault will be there. So when such fault will occur, that time some gases are liberated, okay, from that oil, and uh, these gases are given here. These gases are CO2, hydrocarbon, and CO. Okay, this hydrocarbon gases, carbon dioxide, carbon monoxide will get liberated there from that oil, and when this will liberate, that time your relay will operate there. That time your relay will operate. That's why it is called the gas actuated relay. Okay, and it is mechanically actuated. Okay, it is mechanically actuated relay. So the gases produced due to the decomposition of transformer insulating oil will accumulate in the upper part of Buchholz container, which causes a fall of the oil level in it. Okay, uh, means what actually happens here. So when we are considering that any fault is occurred there, that time that core means that transformer oil get heated. Okay, if any fault will occur, the heat will be produced there. Okay, that core, that winding, and that uh, oil in oil in which that transformer core is placed, that get heated. Okay, and if the oil get heated, okay, means if the temperature of oil increases, what happens, it get decomposed. Okay, if the temperature of any oil increases, then that get decomposed. Okay, so means decomposition of that oil get takes place, and it will produce some gases. Okay, and that oil will also accumulate in the upper part of the Buchholz container, and it will cause the fall of oil level in it. Okay, means if that decomposed oil will accumulate on the upper part, okay, that time what happens, the whatever be the oil in the transformer tank, that oil level get reduced there. Okay, oil level get reduced, so that will again increase the heat. Okay, again increase the heat, and your relay will actuate there. Okay, sometimes due to oil leakage on the main tank, air bubbles may be accumulated on the upper part. Okay, means if there is a oil leakage on main tank, okay, that time what will happen, air bubbles will be accumulated on the upper part of this container, Buchholz container, and it will also cause the fall of oil level, and the alarm will be energized. Okay, means there is alarm circuit. Means if any fault will occur in the transformer, then this relay will sense that fault, and it gives alarm, so that manually we can uh, s- turn off the uh, means that supply to that transformer. Okay, so that's why it is called the manually actuated relay. This Buchholz relay is manually actuated relay. Okay, now this is the transformer it's shown, and where actually this Buchholz relay is placed here. Okay, all of you know the transformer construction. Okay, core is there, windings, bushings are there. Okay, this is your oil. Then uh, there will be breathers. Okay, so Buchholz relay is there, and conservator is there for oil levels. Okay, so here we are using this Buchholz relay in between this transformer tank and the conservator. So in MCQ question also, they are asking the location of Buchholz relay, where actually the Buchholz relay is located. So that time you have to answer the question there. Okay, so it is located between the transformer tank. Remember, transformer tank and the conservator. Okay, and the conservator. Now here the same diagram is there, which is showing this Buchholz relay. Okay, so here actually in that Buchholz relay, there are different terminals. Means normally open and normally closed terminals are there. There is one float. Okay, म्हणजे एखादा जर फॉल्ट ऑकर झाला तर काय होतं, ते कॉन्टॅक्ट क्लोज होतात. ओके, दॅट कॉन्टॅक्ट गेट क्लोज, and that signal is given to the circuit breaker. That signal is given to the circuit breaker for the operation. Okay, or and also it is connected to the alarm circuit, so that uh, it will give signal to the operator. Okay, so this is the Buchholz relay. This is important. It is asked in examination also. Okay, so there is a one more circuit diagram. You can explain that also, uh, or you can explain this one also. But you should know the concept of this Buchholz relay, which is used for the protection of the transformer. Okay, then next point is the protection against the overfluxing. Overfluxing means what? Can anyone tell me what is mean by this overfluxing? Yes, but Buchholz relay समजलाय का? Yes or no? Buchholz relay. Sagar, Sagar, Shivani, Sonal,
Yes, ma'am.
समजलाय ना Buchholz relay?
हाँ, ma'am. हाँ, yes, ma'am.
Okay, okay. Now next one is the protection against overfluxing. Overfluxing means what? Can anyone tell me? Overfluxing means, so what happens? Actually, all of you know the equation, EMF equation of transformer. What is EMF equation of transformer? Yes, EMF equation of transformer. Anyone?
4.44 FIM.
What is equal to 4.44 FIM? Yes, what is equal to? And is it right? Yes. Okay. So when we are considering the EMF equation, so that EMF equation is E1 is equal to 4.44 FIM into N1, right? Na? N1, and E2 is equal to 4.44 Fi2 N2, means if we are considering the normal condition, means suppose we are considering only the primary side. Okay, when we are considering only the primary side, that time that supply voltage, or we can consider the induced EMF here, which is equal to that supply voltage. If we are considering an ideal transformer, okay, that time, so it is equal to 4.44 FIM into N1. Okay, 4.44 FIM into N1. N1 means we can, for general, we can consider only N number of turns. Okay, so this is the relation between the flux and applied voltage. Okay, so this V is the RMS value of voltage. This 4.44 is constant. This F is the supply frequency. This phi m is the maximum flux. And this N is the number of turns. Okay, number of turns of the winding. But sometimes what happens? There is a over voltage. Over voltage means what? We are giving some higher value of voltage. We are applying some higher value of voltage. Then what will happen? What will happen? Okay, so here, uh, you can see actually this is same equation, but only in different term it is given. So for your understanding, you can consider this equation. So here we can write as phi m is equal to this phi m is equal to V divided by 4.44 F into N. Okay, means what? This flux produced is proportional to the applied voltage, right? No, it is proportional to the applied voltage. Means if we increase this voltage, then the flux set in that core or maximum flux in the core will also increase. Okay, so we have to protect our transformer against such cases. Okay, so the transformer overflux protection is provided to protect transformer core from overfluxing. We know that what happens actually when we are considering the transformer core. So that time there is a primary winding and secondary winding is there, right? Primary and secondary winding is there. When we are applying some voltage here, then current will flow through that circuit. That current is I1 and it is setting the flux. Okay, it is setting the flux. So if you apply the maximum value of current, okay, then what will happen? There will be flux set in the core, but uh, this core also has its some capability of producing the flux. Okay, means if this core gets saturated, if the core gets saturated, after that if you increase value of this current after saturation of core, if you increase value of current, then the flux will not increase. The flux will not increase. That's why there is a BH curve. Yes, na? There is a BH curve. This B and this is H. P is the magnetic flux density and this H is the magnetic field intensity. This B is equal to pi divided by A and this H is equal to IN divided by L. IN divided by L. Now here area of that core is constant. Here the number of turns are constant. Length of the core also constant. Means your H is varying with current I and your B is varying with flux phi. Right? Na? So if I increase at start, what happens when I'm increasing this current? That time flux will also increase in the core, right? Na? Right? Na? If I increase value of current, then flux in the core will also increase. But when this core gets saturated, when the core gets saturated, that time what happens? If I increase value of current, then the flux do not increase. Your flux remains constant. That is nothing but your BH curve. Okay. So here this is nothing but the overfluxing. This is nothing but the overfluxing. Here what is given, a transformer is designed to operate at a particular flux level. बरोबर ना? म्हणजे ज्यावेळी आपण एखादा कोर सिलेक्ट करतो त्यावेळी त्या प्रत्येक कोरची काहीतरी कपॅसिटी आहे. ओके, so you have studied that also, different types of cores in that electrical machine design. Okay, so every core will produce its own flux. So in case the flux in the core of transformer exceeds certain level, the core loss increases, which may lead to overheating of the components. Okay, and which in turn may result into internal fault. मग काय होणार आहे? If the capacity of this transformer to produce flux overs, then still you are giving current, still you are increasing current. What will happen? what will happen? Okay, so it will overheat the transformer. Okay, it will overheat the transformer, and there may be the winding loss or the core loss. Okay, that's why we have to protect this transformer against this overfluxing. Okay, so a transformer is designed to operate at or below the maximum magnetic flux density in the transformer core. ओके, म्हणजे असा ट्रान्सफॉर्मर डिझाईन करायचा की मॅक्सिमम फ्लक्स डेन्सिटी जेवढी आहे ना त्याच्या खाली तो ऑपरेट झाला पाहिजे. ओके, सो that's why the formula is Bm, or this B is equal to phi divided by A. Means when in the formula of your this induced EMF, this E, V is equal to 4.44 F phi m. It is the maximum flux and number of turns. Okay, so that time here we are taking Bm, that is the maximum flux density. Okay, maximum flux density means we can write the formula as Bm into A instead of this phi m. Okay, so about this design, limit the eddy currents in the core and nearby conductive components cause overheating, which within a very short time may cause severe loss. Okay, so if we increase value of this current or value of that flux, okay, beyond the given limit, that is beyond the maximum magnetic flux, okay, then what will happen? It will overheat the transformer, and within a very short time, your transformer will get damaged there. Okay, your transformer will get damaged. Okay, so here we are using a core which is means that core is designed up to that much value only. Okay, means some value is set, so above that you cannot increase the current only. Okay, so here when a transformer core is overexcited, the core is operating in a non-linear magnetic region. Okay, non-linear magnetic region, and create harmonic components in the exciting current. म्हणजे when it is under normal condition, okay, when it is under normal condition means not overexcited, means current is given as per the given value only, that time there is a linear characteristic. Okay, means your current is increasing, in that level only your flux is increasing. But when this transformer core is overexcited, means when you are giving the more current, when you are supplying more current, that time you are getting the non-linear characteristic, that is this one characteristic. So it will create the harmonics. Okay, and these are again dangerous to the transformer. Okay, so when we are considering that transformer primary is connected to 220 kV transmission line is there, thus normal voltage of primary of transformer is 220 kV and at a frequency of 50 Hz. So if we are using the potential transformer and this PT ratio is 220 by 110 volt. Okay, so when we are using the current transformers, that time that secondary side current is 5 ampere, and when we are using potential transformers, that time potential is 110 volt. Okay, So this is 220 kV transmission line. By using potential transformer, we are reducing voltage to 110 volt only. Therefore, this V by F ratio is 110 divided by that CT secondary voltage is 110 volt and divided by F frequency is 50 hertz. Okay, म्हणजे 2.2 म्हणजे हा जो रेशो आहे V by F ratio. So you have to operate your transformer within or below this limit only. Okay, so if it will exceed, then there will be the fault. Okay, there will be the fault occur and it will damage the transformer. Okay, म्हणजे ही जी व्हॅल्यू दिली इथपर्यंतच तुम्ही V by F रेशो जो आहे, V by F means from this equation only you are taking this here. Okay, V by F. This is V by F is equal to right side la 4.44, it is 5m into it will change according to your transmission line voltage and whatever PTs you are connecting. PT will be same, but means as per the devices you are connecting, according to that your level of that V by F ratio will change. Okay, it will change there. Okay, so what you will do when there is overfluxing in the transformer? What you will do? First, overfluxing means what? If we are giving some extra current after saturation of the core, this overfluxing hits the transformer and transformer core, which will damage. Okay, so what we have to do? We have to set the V by F ratio for that transformer. So up to that only we can give the current. We can apply the current, and beyond that, uh, your transformer will become faulty again, or it will get damaged here. So that is your limit. That is your limit. So when this V by F ratio is given, that is nothing but your limit. So here our transformer protection is over now. Okay. So in next lecture, we'll see the generator protection. Induction motor protection is there. So in this chapter, this differential protection scheme is frequently asked. That's why I study that point. Also, in that differential protection scheme, actually, there are again different types. We are going to perform practical on this transformer, and that is we are using that differential protection scheme again. Percentage differential protection relay we use there. So we will perform that practical also. Fourth experiment is there. So we'll take that. And in this transformer, that percentage differential protection is important. That is asked many times in examination. Then sometimes the faults occurring in the transformer are also asked in exam. Then These two questions are important, and they may ask you overfluxing also, and different protection schemes. म्हणजे इथे आपण ऍक्च्युली एक डायग्राम कन्सिडर केले इथे. when we are connecting this transformer in star and delta. ओके, जर स्टार दोन्हीकडे ग्राउंड केलेले आहेत लक्षात असू, अँड वी कॅन कन्सिडर दिस ट्रान्सफॉर्मर कनेक्शन ॲज स्टार अँड स्टार. ओके, star star connection also. So if we are using here star and star, CT should be connected as delta and delta. Okay, so that you should remember here. So they may ask you any or they may mention or will give only the differential protection scheme. That time you have to draw the correct diagram. Practice this diagram, important one. Transformer faults, then differential protection, and the last point, that is overfluxing, is asked in examination. So complete or concentrate on these points, and the basics are already there. Then in generator protection, again there is a differential protection scheme. म्हणजे हे जे सेम प्रिन्सिपल आहे ना, दॅट इज युज्ड इन जनरेटर प्रोटेक्शन ऑल्सो. देर इज अर्थ फॉल्ट प्रोटेक्शन इज ऑल्सो देअर. सो again what is changing here, this diagram will remain same, only here instead of transformer we are putting their generator. Okay, otherwise the scheme is same there also. Okay, in the generator protection scheme. So any doubts anyone want to ask? Yes, if anyone want to ask anything. आणि ISC is only on first section. I already told you ISC is only on the first section, that is first 3 chapters, and notes of these first 3 chapters are already uploaded on the drive. Okay, you can refer these notes, and today there is paper of switchgear and protection. So any doubt anyone want to ask? Shubham, Payal?
No, ma'am.
Okay. You can refer the MCQs which Hello. Sorry, there was a call of HOD, ma'am. Okay. Okay, so is there any doubt? Kai doubt आहे का for switch gear protection? Yes or no? Okay, I think no any doubts. Okay, no problem. For today, we'll stop here. Thank you all. Have a nice day and all the best for examination. And everyone refer notes. You can take reference of other notes or also or of internet also. Okay, but prepare and study and don't copy. Just try yourself only. Don't copy the answers. Okay. Okay. Thank you. We'll end lecture now. Thank you.